Hi, this is Geometry, Lesson 1-8, Indirect Proof. In this lesson, we'll be able to use indirect reasoning to arrive at a proof. Let's start with critique and explain. Philip represents the following number puzzle to his friends. If you look at his phone, what do you see? It says that the number is a prime number. The square of the number is less than 100 and greater than 10. The number is not a factor of 21. What is the number? Part A. Philip states that the number must be 7. Explain why this cannot be true. We're telling you that this number cannot be true. Why? Does any of the statement not work for it? Is 7 a prime number? Yeah, it's a prime number. So that's satisfied. What about the square of the number is less than 100 and greater than 10? 7 squared is 49. So it is less than 100 and greater than 10. So yeah, that works. The number is not a factor of 21. The factors of 21 is 1, 3, 7, and 21. So it is a factor of 21. So no, that doesn't work. It cannot be 7. Right? He is wrong. Because 7 is a factor of 21. Part B, write your own number puzzle that has an answer of 5. Your friend says the answer is not 5. How do you use the statements of your puzzle to identify the contradiction? So write your own puzzle like that, where the answer must be 5. Let's try to copy this idea and try to figure out if it's a prime number, composite, what is the square of that number, and is it a factor of something, or can it not be a factor of something, right? So let's say the number is a prime number because 5 is a prime number. Okay. The square of the number is 5 squared is 25, so it's less than 100 and greater than 10. We could use the same thing. What about the last one? Is 5 a factor of 21? No, so we can use the same thing as well. The number is not a factor of 21. And your friend says the answer is not 5. How do you use the statements of your puzzle to identify? 5 is a prime number. 5 squared is 25, which is less than 100 and greater than 10. And 5 is not a factor of 21 because factor of 21 is 1, 3, 7, and 21. And 5 is not there. There you go. So think about this essential question throughout this lesson. What can you conclude when valid reasoning leads to a contradiction? What if there's a contradiction between your friends, between an argument, or between statements? So one of them has to be wrong, or maybe both of them could be right in different ways. We'll see. Let's look at example 1. Use indirect reasoning. What is an indirect reasoning? Beth is having a dinner with Sarah and one of Sarah's friends, Libby, Kelly, or Mercedes. Beth orders a chicken and spinach pizza to share for dinner. First of all, Libby is a vegetarian, so she probably will not eat chicken pizza. She'll not eat chicken. And Mercedes is at the library. Okay. Kelly is allergic to mushrooms. Who is having dinner with Beth? Use indirect reasoning to determine who is having dinner with Beth. So we don't know who that person is, but if Beth orders a chicken and spinach pizza to share for dinner, she doesn't want to be disrespectful and order something that's not vegetarian for Libby. So we're gonna cross Libby out. What about Mercedes? She's at the library, which means she's not at the dinner. So no. Kelly is allergic to mushrooms, and none of the dishes she ordered may have mushrooms. So probably Kelly would be having dinner with Beth. So Beth must be having dinner with Sarah, and Kelly would be an indirect reasoning. So we still don't know for sure. Like, of course, there is a possibility that Libby could be there, or maybe Mercedes is running late, But yeah, there could be other reasons why she ordered chicken and spinach pizza, but there is a limited amount of information we know. And using that information, we're using indirect reasoning to figure out some things, right? So this is called indirect reasoning. It's not as strong as direct reasoning, but it is still a reasoning skill. Let's look at try number 1. Use indirect reasoning to draw a conclusion in the following situation. A bagel shop gives customers a free bagel on their birthday. Thada went to the bagel shop today but did not get a free bagel. So what do you think? Okay, so what is a conclusion that you can make using this information? You can say that it's not Thada's birthday because he didn't get a free bagel, right? Did you get it? Good job. Let's look at the next page. There's a concept, writing an indirect proof by contradiction. A proof that uses indirect reasoning is an indirect proof. Use an indirect proof when a direct proof is impossible. Of course, if you can use direct proof, you should use that. Two types of indirect proof are proof by contradiction and proof by contrapositive. Okay, so we're going to look at proof by contradiction here. A statement is given as a conditional. If P, then Q. Step 1, you're going to assume P and not Q are true. So if P, then not Q. And then you're going to show that the assumption not Q leads to a contradiction. Maybe there's a problem. Maybe it doesn't work. Maybe it doesn't make sense. And you're going to conclude that Q must be true because the statement is not true. Okay. Let's look at example 2 to write an indirect proof by contradiction. Okay. If Eleni walks more than 8 kilometers over a 2-day period, then she walks more than 4 kilometers on one or both days. So first, the first step, you should identify the hypothesis and conclusion. So P is the hypothesis. Eleni walks more than 8 kilometers over a 2-day period. And then she walks more than 4 kilometers on one or both days would be our conclusion. So the statement has to form if P then Q, which is called the conditional statement. So step 1, we're going to assume that the opposite, if P then not Q, are true. So what is not Q? We're going to change the Q statement into a negation. So Eleni does not walk more than 4 kilometers on either day would be the entire opposite of the conclusion we have in the conditional statement. And then step 2, show the assumption not Q leads to a contradiction. So if Eleni walks more than 8 kilometers over a 2-day period, then does that mean she doesn't walk more than 4 kilometers on either day? Is there a way that she doesn't walk more than 4 kilometers on either day? If she doesn't walk more than 4 kilometers on either day, there is no way the total distance she walks over the 2-day period must is more than or equal to 8 kilometers. It should be less than or equal to 8 kilometers, right? So this contradicts the hypothesis P. And now we can conclude that Q must be true. Just note that this is an indirect proof. So we're concluding that it must be true, but there might be possibilities that it is not actually true either. But it is still a reasoning skill if we cannot use deductive reasoning. So because the assumption leads to a contradiction, we can say Q must be true. Melanie walks more than 4 kilometers on one or both days. A lot of times it works. A lot of times it is true. Sometimes indirect reasoning is not as strong as direct reasoning. So it will have some flaws. Let's try number 2. Write an indirect proof for each statement using proof by contradiction. So try to write an indirect proof for each statement A and B. See if you can do it by yourself. Come back when you're ready for answer. Okay, are you ready? Yeah, part A. If today is a weekend day, then it is Saturday or Sunday. Use indirect reasoning. So we're going to assume if today is a weekend day, then it is not Saturday nor Sunday. Okay, that is the negation of our conclusion. So we can assume that the conclusion is not true. That today is not Saturday or Sunday. Then, therefore, today is a weekday. This contradicts the hypothesis, right? So the assumption is not true. The statement is true. The assumption is not true, so the statement is true. What about part B? If you draw an angle that is greater than 90 degrees, it must be obtuse. So what is the assumption we could make? We can assume that the conclusion is not true, which will mean that the angle is not obtuse. Therefore, what can we conclude? The measure of the angle is less than or equal to 90 degrees if it's not obtuse. Obtuse angles are angles greater than 90 degrees. Angles that are smaller than 90 degrees would be called acute angles. Okay? Therefore, the measure of the angle is less than or equal to 90 degrees, which contradicts the hypothesis. So the assumption is not true, so the statement is true. Whoops, I have so many cells, so I'm gonna change that. Okay, that is indirect proof for you. Let's look at a concept. Writing an indirect proof by contrapositive. This is another way to prove by using indirect proof. Conditional if P then Q and is contrapositive. If not Q, then not P are logically equivalent, so they have the same truth value. If you remember the truth table, the conditional and its contrapositive are logically equivalent. They're logically the same thing. So they have the same truth value. And so if you prove the contrapositive to be true, then you also have proven the conditional to be true. So we're going to prove by contrapositive, which is logically equivalent to the conditional. So assume the conclusion is true, and you can show that the assumption leads to the negation of the conclusion is true, then that leads to the negation of the hypothesis, which shows if not Q, then not P, right? And then you can conclude that means if P, then Q must be true. So let's practice. Example 3. Write an indirect proof by contrapositive. Look at this statement. For two positive integers, n and m, if n, m is greater than 16, then either m or m is greater than 4, or both are greater than 4. We're going to write the negations of P and Q. What are the P and Q? The number has to be two positive integers, n and m, greater than 16 is P, right? N, m greater than 16. Then either n or m is greater than 4, or both are greater than 4 is Q. So we're gonna write a negation for them. Not P would be n and m less than or equal to 16. Make sure you include the equals to, because if it's not greater than 16, it also being 16 also contradicts that statement. So anything that contradicts is a negation, okay? And the negation of the conclusion would be n less than or equal to 4, and instead of or, right? And m is less than or equal to 4. Okay, it has to be both. This is a part of the contrapositive you will assume, and this not P would be the part of the contrapositive you prove. So we're going to assume that not Q is true. We're going to assume that n less than or equal to 4 and m is less than or equal to 4. So we're going to show that assumption leads to not P, that n times m is going to be less than or equal to 16. So if it's greater than or less than or equal to 4, if they're both less than or equal to 4, the greatest number they can get is 4, right? So 4 times 4 is 16. And so that proves that the greatest number they can get is 16, and it's not going to be greater than 16. So that's a contradiction. By writing these expressions, you can say nm must be less than or equal to 4n, because the greatest number n could be is 4, right? So it could be either equal to or less than 4m. Same way for m as well. So by the transitive property, nm is less than or equal to 16. So therefore, not Q, then not P. And we can conclude that if P, then Q must be true. So proving the contrapositive proves the conditional. So therefore, for two positive integers n and m, if n, m is greater than 16, then either n or m is greater than 4, or both are greater than 4. So why do we use indirect proof now? In this case, there are many cases that we need for direct proving, right? We can't test all the cases. So sometimes, in this case, cases like this, it is actually more effective to use indirect reasoning to prove something, right? So let's try number 3. Write an indirect proof of each statement using proof by contrapositive. If today is Wednesday, then tomorrow is Thursday. Write a negation for both the hypothesis and conclusion, and use an indirect reasoning by contrapositive. If a whole number is between 1 and 4, it is a factor of 6. See if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? All right, what is the negation of the hypothesis and the conclusion? If today is Wednesday, if today, so not P would be today is not Wednesday. Not Q would be tomorrow is not Thursday, right? So we're going to assume that tomorrow is not Thursday. If tomorrow is not Thursday, it could be any days other than Wednesday, right? Wednesday is the only day where the next day is Thursday. So it doesn't make sense that today is not Wednesday. Yeah, so, okay, where was I? Yeah, so we're gonna assume that the conclusion is not true. We're gonna assume that that tomorrow is not Thursday. And if tomorrow is not Thursday, then today is not Wednesday, right? So we have proven the negation of the hypothesis. So which means the contrapositive is true. So the statement must be true. All right. That wasn't too hard. Okay, what about part B? If a whole number is between 1 and 4, it is a factor of 6. So the negation of the hypothesis is that the whole number is not between 1 and 4. Okay? Is not. So we're going to try to prove that. It is not a factor of 6, and we're going to assume this. Okay, so let's assume that the conclusion is not true. The whole numbers between 1 and 4 are 2 and 3, right? The only whole numbers that are between 1 and 4 are 2 and 3. And both are factors of 6. That the whole number is a factor of 6. Right? So it must not be between 1 and 4 if it is a factor of 6. So the contrapositive is true. So the statement must be true. There you go. That is called an indirect proof by using contrapositive. All right, that was it, guys. Let's summarize our lesson. So what did we learn? Indirect proof of conditional statement by contradiction or by contrapositive are shown. So steps for proving by contradiction. Assume P and not Q are true, and you're going to show the assumption not Q leads to a contradiction, and you're going to conclude that Q must be true. An indirect proof by contrapositive is when you assume that not Q is true, and you're going to prove that it leads to not P. And because the contrapositive is true, logically it is the same as the conditional statement. So conclude that the conditional must be true. They're slightly different, but they're both using indirect reasoning to reach the conclusion. Or the proof. Okay, that was the last lesson of the first topic. If you have any more questions, please ask Ms. Kang in class. Otherwise, we'll continue with the next topic in the next video. Bye!